This is slide 15 of the chapter 2 PowerPoint, and I created this terrible histogram using Google Forms. After I did that survey, this is how it presents the data. And we talked, I think, in the previous chapter slides why this isn't correct. The horizontal axis is not scaled consistently. Also, there's just too many categories. So the classes, or the bars, a rule of thumb is to have 5 to 15. Square root of the number of data values and round up. I believe we had, how many data values did we have here? Okay, so I just went and checked, and there are 169 data values, and the square root of 169 is 13. So that rule of thumb, which is just a rule of thumb, says 13 categories would be adequate or okay. So I created several different histograms, and we're going to look at them and see what we think. I thought the numbers would just be nice if we went by 5-year increments. So this does not have 13 classes. This only has 6 classes. And I think that Google Sheets has a histogram feature now. I think when I made this slide, it did not. So this Google Sheets is not making a histogram here because the bars have gaps between them. But it is possible, and I think that might be an update. If we try smaller classes, so this is 3-year increments instead of 5-year increments, then we're going to have more classes. And notice that rule that we talked about before, a 58-year-old is going to be counted in this category, not this category. "13 classes might be fine, or it might be too many." So I think this is a reasonably detailed graph. And again, I said histogram, and there's gaps between the bars. That's not actually the way it's supposed to be. Now here's a real histogram, and I used Desmos, and these, I don't remember if these are the potatoes. I guess I could check the data from the activity. So this is, I believe, the potato. So I was able to mess with the settings and get this to work. And so this is quite elaborate, and I would like to teach you how to use Desmos for your data. But what I did was I put in all of the apple weights. You just tell Desmos A equals, and then you give it the list. And then in the next box, you say histogram A, 20. But I have the apples turned off right now. And the red bars are the potatoes. So again, I gave Desmos all the weights of the potatoes. There were 12 potatoes. And then I said histogram P, 20, and there's the histogram. The frequency of all of these is 1. This is 2, 2, and this is 3. So there was that one really big potato that's over here. And notice that the x-axis is the weight in grams, and it's a number line. And then this will be different depending on the bin alignment, which I typically stick with left bin alignment. And then we could turn the potatoes off and the onions on. So that's what the onions looked like. That's what the potatoes looked like. And those were the apples. The apples were much more consistent in weight. They were almost all in the same or close to the same weight, but there was a lot of variation in onions and potatoes. So I like that I'm researching produce in this case. Going back to our PowerPoint, so Desmos creates a very good histogram. And I can change the class size for the potatoes from 20 grams, which I think is what I had there, to a 50-gram size, which is just like more general and less information, more chunky. And it's basically a frequency distribution. So you get to see, oh, there's not that many people in the shorter heights, and then we have a lot of people in the more popular heights, and then we get fewer and fewer very tall people, which is what you would expect in a class. So that's a distribution. Time to school in minutes. So this is two different terms. And the data is how long it took them to go to school, and the frequency is on the vertical axis for those two terms. And then in the second graph, I do relative frequency. And you can see that the vertical axis is now a decimal, and that really represents a percentage. So but the shape of the graph is basically exactly the same. So not a huge difference between a frequency histogram or a relative frequency histogram. Okay, just a couple more slides in this video. Here's a histogram that's skewed to the right. There's not that many people who have a really long commute to work. So the bulk of the data is to the left. That tends to confuse people, but the histogram is skewed to the right. So those few people with a really long commute are skewing the data. And that makes the mean be higher than the median. These data are skewed to the left, so the mean would be lower than the median. And this survey question, it's not perfectly even, but it's fairly even. So it's a somewhat uniform distribution. It's not like we're tapering off in January and December. We're staying relatively flat across these months. And I wouldn't mind checking out an updated graph for this now that I've got more data values. I wonder if this got flatter, because September was strangely low, wasn't it? I can understand February being a little bit lower because it's a shorter month, but it's a lot lower.